Hello everyone and welcome to this presentation which is all about proportional relationships and their graphs. I would hope that you have seen all of what I'm going to show you on these 4 slides at GCSE level, but we will recap what you have already learnt, and if there's anything on here that you haven't seen before, then that's good. You'll be learning something new. Any problems, speak to your class teachers. So here is an example of direct proportion. The amount that you earn is directly proportional to the number of hours you work, and you will see there that I have designated variables to each of those things. So y is the amount we earn, x is the number of hours we work. And rather than be too general with that, underneath you will see that I've got an actual value for the amount that I get paid per hour. So from that I can write an equation, because if I don't work any hours, if x is 0, then y will be 0 because I won't earn anything. If I work for 1 hour, so when x is 1, I will get paid £6, so y would be 6. If I work for 2 hours for x, I will get paid £12. For y, double the amount that I earned when I only worked 1 hour. So from that we can produce quite a simple equation, y equals 6x. If I know how many hours I work, I just replace x with that value and it will work out for me how much I'm going to get paid. And from that we can then draw a graph with x along the bottom. These are the number of hours worked and the amount that I earn up the side. So there is a direct proportionality graph going through the origin, and as x doubles, y doubles, etc. And from that graph we can then estimate how many hours I would need to work to earn certain amounts of money. The graph will also tell me how much I would earn if I knew how many hours I worked. So I could use either the equation or I could use the graph to work that out. So if I was to use the graph, I would need to find £400 on the y-axis, and then taking that across and down as accurately as you can, we can then read off how many hours I would have to work, which is roughly equal to 67. Good, so what we will do now is in your notebooks we'll write down some notation that we use concerning proportionality. Again, I imagine that most of you will have seen this before, but it's important that we have those notes in our notebook before moving on. So first of all, if y is directly proportional to x, there is a symbol that we can use to represent that, and that is this symbol here. Y is directly proportional to x, and then we will often have to change that into an equation. And in order to do that, we need a constant of proportion, and the letter that we use to represent that constant is k. So we would multiply the right hand side by that value of k, and that would be required in order for us to change it into an equation, and the equation would look like this. You'll notice that that looks very similar to the y equals 6x that we had on the previous slide. But this is a very general form where I don't know the value of k. If I wanted to find the value of k, I would need to have been given some other information. I would need to know an x and a y value that I can sub into this equation, allowing me to find the value of k. So still in our notebooks, we're going to take that slightly further now by looking at when y is directly proportional to the variable x to the power of n. So same again, this is still a direct proportionality question. So if I was to write it as a statement, it would be written like this: y is directly proportional to x to the power of n. And then if I want to change that into an equation, I need to use again my constant of proportion, my proportionality constant, which is always denoted by the letter k, and that would create the equation y equals k times x to the power of n. And again, that's as far as I can go with this. I don't have any values to sub in, but if I did know a value of x and y and a power of n, then I could go on and find the value of k. Once I've found k, with it being a constant, once I've found k, then that's going to stay at that value of k for every question then that I do concerning this situation. The other example that we get is when y is inversely proportional to x to the power of n. We don't have to learn any new symbols, we just have to write our statement in a slightly different way, and the way that we would write that is y is proportional to 1 over x to the power of n. And again, I would expect you to have seen this at GCSE level. If I then want to change that into an equation, be careful about that constant of proportion, because when I multiply that right hand side by that value of k, the k will go to the top of the fraction, not the bottom. So be careful. Our equation that includes that value of k would look like this, because we've multiplied the fraction by k, and therefore the numerator changes, not the denominator. Okay, good. So quite a short presentation this one, but let's see what we've learned and what we need to recap. So on page 44, exercise 3.1, have a go. Any problems, ask your classroom teacher, and that completes our presentation on proportionality.